Right, so here's the practice final. Starting with some relatively basic multiple choice questions. So the exact value of tangent of pi over 6, we just have to go back to the unit circle for that. It's going to be root 3 over 3. Exact value of sine of negative 1/2 should be negative pi over 6. Since we have to do the inverse sine of a negative number, we'll end up in that negative fourth quadrant. 4, y equals 4 tangent of x plus pi over 3. Two consecutive vertical asymptotes are, well, let's just solve for some. We'll take that inside, which is x plus pi over 3, and set it equal to pi over 2 plus k pi, since that's the formula for the asymptotes of tangent. Scoot that down a little bit so maybe it isn't in the way of those pictures. And solve that thing for x. Pi over 2 minus pi over 3 is going to be pi over 6 plus k pi. And then we'll just plug in a couple values for k. So x is going to be pi over 6 plus 0. Hopefully I hit the mute button in time to catch that sneeze. Okay, so pi over 6 plus 0 is going to be pi over 6. And then we'll take pi over 6 plus 1 k pi and get 7 pi over 6. So option E. All right, and then we'll convert rectangular coordinates into polar coordinates and figure out what we get. Okay. So we know that tan theta is equal to 3 over negative 3, which is negative 1. So theta is probably going to be 3 pi over 4 or 7 pi over 4. Looking at our coordinate, we have a positive x value and a negative y value, which means we're in quadrant 4. So looks like we want option E. Because we'll also see that r squared ends up being, or r squared is going to be 18, since 3 squared plus 3 squared is 18. So 3 square root of 2 is r. All right, an exact value for the cosecant of 7 pi over 3. So if we take 7 pi over 3 and subtract 2 pi, we get pi over 3. So 7 pi over 3 is coterminal to pi over 3, so it should have the same cosecant value as pi over 3, which will be d, 2 root 3 over 3. So that'll just be the reciprocal of root 3 over 2. And a medical helicopter is 120 miles due south and 15 miles due east of a hospital. Pilot wants to travel directly to said hospital. What bearing should be taken? Okay, so we need to go south and then east. Yeah. Right, so that's about what our thing looks like. So that we have helicopter and hospital both start with H. That's unfortunate. So hospital's up there, helicopter's down here. And what did we want? The bearing that the pilot's going to need to go directly to that hospital. So hey, the bearing that we want is going to be that angle. So how do we want to go about getting that? We know this is 120 and that's 15. I guess we'll start by getting theta down here. And if I'm looking for theta, I know my opposite side and my adjacent side. So I'll use an inverse tangent something down here. Theta should be equal to, theta should be equal to the inverse tangent of 120 over 15. And we'll pop that into a calculator. And it turns out that that's 82.87 degrees. And then we need our bearing angle, which should be 90 minus that 82.87, which will be 7.13. And we need to go to the northwest in order to get there, so that bearing must be the 7.13 degrees to the northwest. Oh yeah, this video is definitely going to be uploaded later. Yep. All right, and problem 7, for an object in simple harmonic motion given by the model d equals -5 sine 4t, or 4 pi t, d is in seconds, or d is in feet, t is in seconds. I can read my own test. And the frequency is in oscillations per second. Find the maximum displacement and the frequency. There we go. Okay, so that maximum displacement, it should be just 5, because we'll take the absolute value of -5. So we just need to come up with that frequency. And oh my, we've started to run out of space. Let me take all of this work and just slide it up a little bit. There we go. So frequency is 1 over the period, which is equal to b over 2 pi. So 4 pi over 2 pi, which means it's going to come out to 2. So option E. Maximum displacement of 5 and a frequency of 2 oscillations per second. All right, and then we've got an arc length problem. So we have a central angle of 100 degrees and a diameter of 4 feet. Oh, how did I know it was positive 5? So the maximum displacement is always positive. So I just want the, uh, it's basically asking for the amplitude, right? And the amplitude is the absolute value of A. So the absolute value of -5. Because the maximum displacement is just going to be the same thing as the amplitude. Then number 8, we need a couple of things. We need to know the radius, which in our case should be 2, since we're given a diameter of 4 feet. And we also need theta, but theta is must be in radians. So for anyone watching the video later, there's a question in the chat. It says, would the minimum displacement be negative from back in problem 7? Technically, the minimum displacement would be 0 if we wanted to talk about it, and the minimum displacement would always be 0 for simple harmonic motion, because there will be a point where it's back at its rest position, even if only for a moment. But the displacement, when we're talking about a maximum displacement or a minimum displacement or just displacement in general, it will never be negative. So it'll always be some positive number. Because again, maximum displacement is really just a way of talking about the amplitude, and the amplitude is always an absolute value. But if we come back to 8, we're converting our 100 degrees into radians. And it looks like that is 5 pi over 9. Yeah. Just to slide that over a little bit. All right, and finally, let's get the arc length. S is r theta. So 2 times 5 pi over 9 is 10 pi over 9. So option C. So another question out of the chat. Can we open web work while taking the final exam? I can't remember from the beginning of the semester, said it's prohibited. So every exam is open note, just in the general sense of being open note. So yeah, I suppose you could have web work open on the exam if you wanted to. It's not like I'd ever know anyway. So, but yeah, if you want to have web work open, that's fine by me. I think the one thing that you're not able to do is open up an old quiz or an old exam at the same time as a final. And that's not necessarily by rule, but just because I don't think D2L will let you. But yeah. That'll be cool. Polar equation down here. If r is equal to 4 over secant theta, that would be the same thing as r equals 4 cosine theta. Since cosine is the reciprocal of secant, or rather secant's the reciprocal of cosine. And then I'm going to take that equation and multiply by r so that I get r squared is equal to 4r cosine theta. And then this is a relatively straightforward substitution for polar coordinates. X squared plus y squared is equal to 4x. So we just need to find the one that matches that. Looks like it's option E. Okay, and now we want to solve some triangles. So given this information, solve the following stuff. So we're given two angles right off the bat. So we'll start by solving for the missing third angle. That should just be 180 minus the other two. So add those two up and we get 97. So well, it must be 83 degrees here for A. Yeah. All right, and then it's law of sines from here on out. Let's mark that in blue. So to get B, I'll have B over sine of B, which is 34 degrees. And that should be equal to 3.2 divided by the sine of 83 degrees. Meaning B is 3.2. The sine of 34 degrees over the sine of 83 degrees. Oop, that wasn't right. So pop that into a calculator. And we'll see what we get. Will there be one with two triangles on the final? Probably not. I want to say no, just straight up, but I haven't written the final yet. I can decide. You know what? Let's just say no. There won't be a two triangle problem on the final. We'll just leave that off. We'll stick with the basics. If a two triangle problem did show up, it would be similar to the way that it was on exam 4, where I just said, you know, there are two possibilities for angle A, or there are two possible triangles on this problem. Find both angle A's that work. And that's where you had to do inverse sine to get one of them, and then you had to do 180 minus inverse sine for the other. And yeah, if there is going to be a second triangle on the final, I'll straight up say, there's a second triangle on this problem, and then tell you to figure it out from there. Wait, no, I don't want that. I want 3.2 sine over sine. That's not right. Okay, this was 83 degrees goes there, and we had 34 degrees goes there. I got 1.81. No, that's a lie. 1.80. I round correctly. That'll be in inches. And then finally, we'll also want to get C. Let's just skip ahead a little bit in the work. So the only thing that's different between C and B is that I'm going to use angle C instead of angle B. So sine over sine. This should be 63 degrees up there. But I'm still using everything about angle A because I know that stuff exactly. So if I just come back to my calculator and plug in 63 instead, I get 2.87. So A, B, and C are the three things that we needed to solve this triangle, and I got 83 degrees, and then I got 1.8 inches, and then I got 2.87 inches. All right, and then finally we want to find the area of this triangle. And we can use any one of those area formulas that we want. So the first of which was 1/2 AB sine C. If I color code those real quick, this ends up being 1/2 of a bunch of stuff. So A was given, it's 3.2. Green we had to solve for, it's 1.8. And then angle C was 63 degrees. Plug all that into a calculator. There we go. And I got 2.57. That'll be in square inches. All right, on to problem 11. We've got a graph, and we're going to have to figure out what its equation is. So this thing is a sine graph, which is fun, but I guess I'm getting slightly ahead of ourselves. Let's start by grabbing the range. Right, to get the range, I just need to know the minimum value and the maximum value. And that minimum is down at -2, while the maximum is up at 8. -2 is right here. 8 is up there. So we'll use the range to find both our amplitude and our maximum, and our vertical shift. So that amplitude is going to be equal to 8 minus -2 over 2 which simplifies to 5. So we can drop that amplitude in right there. The vertical shift, what color did I use for vertical shift? Man, it's been a minute. Might have been green. Man, this is ages ago. All right, vertical shift. This one is going to be 8 plus -2 all over 2, which works out to 3. Oh, you know what? This one was totally in yellow, wasn't it? I do remember what I put it in now. Okay, so we found a vertical shift and I drew it into the graph because that will help us out. So what do we want to get next? How about the period? Because that we can still read from the graph. The period will be the distance from in between those two red lines. And let's see, that is 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's how I was counting those. Just counting along those boxes. And we have a y or an x scale of 1, meaning that period is just 8. So 8 times 1. Since that scale down there is important. And finally, we need to pick a phase shift. And since this is sine, I could choose any of these points to be the phase shift. Right, any one of those points that hits that center line is a valid phase shift. You just have to pick whichever one you want. And I'll highlight my choice in green. I'm going to pick that one back there. Means my phase shift is -3. Since that value right there is -3. All right, and now from my choices here, I need to get A, B, and C. So A all depends on my choice of the phase shift. I picked a phase shift so that I could end up with a positive sine graph. Since if we look at the green point that I circled, the graph immediately begins moving up after that. So because of the green choice, A is positive, and the phase or the amplitude just gets slotted in right there. Then we want to get B, which is 2 pi over the period. So 2 pi over 8 is pi over 4. Then we want to get C, and C is going to be B multiplied by the phase shift. So pi over 4 times -3 be -3 pi over 4. And then finally, we just have to drop this all into a function. So our function should be 5 times the sine of pi over 4x minus -3 pi over 4 plus 3. All right, so remember that the equation always has the opposite sign of C on the inside. because it's always bx minus c. All right. Okay, problem 12. Ooh, verify a trig identity. Work on only one side and show all your work. All right, so when we have trig identities, usually it makes the most sense to work on the more complicated side. So I'm going to simplify the right side of this thing, starting with the cosecant of pi over 2 minus x. I should be using a cofunction identity here. This will be the secant of x minus cosine is an even function, which means that that negative ends up not mattering. Right, so cosine of negative x is just equal to cosine x. All right, next, what do we want to do? I'll probably change this thing to 1 over cosine x minus cosine x. And then I'd like to get a common denominator here. So I'm going to multiply the right piece by cosine over cosine, which will give me 1 over cosine x minus cosine squared x over cosine x which is 1 minus cosine squared over cosine. Then 1 minus cosine squared is a Pythagorean identity. That'll be sine squared x over cosine x. And then finally, we've just got to start working this answer to look like the one that we were starting with, which was tangent over cosecant. So I'm going to split this thing up into sine x times sine x over cosine x, which sine over cosine simplifies to tangent x, and sine is the reciprocal of cosecant, so that's 1 over cosecant x. And that was the identity we were trying to get to. Tangent over cosecant. So if this problem showed up on the final, which there will be at least one verified trig identity on the final, the last step won't be as awkward as this one, because I think most everything made sense up till here, or at least like all the steps are relatively straightforward to get to that point. And then the last bit, you sort of have to just kind of move some things around until it looks exactly like what was on the left side. Most of the time when I write these problems, one of the two sides will be quite simple, whereas this one had a bunch of extra stuff going on the left side. But all right. 8. Plot and label the following coordinate, the following polar coordinate, and then convert it to rectangular coordinates. So start by looking at negative 2 pi over 3. It'd be the same as 4 pi over 3. So we're looking at that angle. Theta equals negative 2 pi over 3. And then we want to go forward 5 along that line. So 1, 2, 3, 4, 5. Since negative 2 pi over 3 would be in the direction of the third quadrant, because negative 2 pi over 3 is coterminal to 4 pi over 3. So just move along that line in the forward direction, which puts us into the third quadrant. All right. And then to convert this thing to rectangular coordinates, I've got x is equal to 5 cosine of negative 2 pi over 3, which works out to negative 1/2. And then y is 5, not negative 1/2, negative 5 over 2. There we go. 5 sine of negative 2 pi over 3. That'll simplify to negative 5 root 3 over 2. So we'll just plop that into into the point. So negative 5 over 2, negative 5 root 3 over 2. It's that those given parentheses were a little small, so I just crossed them out, made my own. Okay, then we want the exact value of cosecant of tangent inverse of negative 21 over 20. Which means we got to get ourselves a reference triangle. So we're going to call this angle theta right there. Tangent inverse of negative 21 over 20 will be theta. So then I just need to slot those numbers in somewhere. So opposite over adjacent. So 21 goes there, 20 goes here. And we're in the fourth quadrant, so the y value should be negative, and we're missing c, the hypotenuse. So c squared will be equal to 20 squared plus 21 squared, meaning c is the square root of that mess. I don't think. Oops. Oh, 29. Okay, so then we just want the cosecant of that. Cosecant of theta. And that should be hypotenuse over opposite. So negative 29 over 21. Right. How many more problems do we have on this thing? Oh, there's a couple of pages that haven't even loaded. Lots of pages that haven't even loaded. Well, we might not be able to finish in class time. That'll be right. I'll just